Good morning, everyone. So welcome to the fourth part for the lesson 3 for introduction to security. So today I want to introduce the more vision. Okay, more vision, how we can securing the data in the next 20 years. Because this year is 2024, right? So we will see how data security in the next 20 years in the quantum age. Okay, first time we can see what is quantum computer. Why is a kind of maybe game changer. So first, it's quantum is kind of latest achievement can utilize quantum mechanics to solve some very complex problem faster. Okay, faster than classical computers. So if you see in the left side, that's one quantum computer from a Chinese company. And if you will see the right side, you can see comparison between the number of qubits and the corresponding the binary bit in currently the computer network. So you see the quantum computer, they look a bit different, right? So if you see compare with current classical computer, they do not have a kind of chip, very small chip like our currently, but they use kind of the different kind of chip that's called quantum processor. So you can see over there have a lot of circuit, right? You can see a lot of circuit in the screen. And one thing is quite different. You see about just one qubit, they can represent up to about 32 bytes in the binary binary digits compared with classical computer. So now if you increase to about 3 qubits, so you can see they can represent up to about 128 bytes in the right side, you can see. So that means in quantum computer, you just use 7,000 bits, you can equal to kind of supercomputers in a classical way. And you see in the last column in the right side is n qubits, it equal to kind of 2 exponent n plus 4. So with n qubits, the quantum computer can solve a very complicated problem. It's much faster, and the model or some optimization become less complex. So that is the key point for the difference between the quantum computer and classical computer. And several facts you can see the quantum computer still very challenging to manage currently because they require very cold environment. They may be up to about minus 459 degree Fahrenheit, okay, and or something like minus 273 degree. That is very cold, very cold. And manage this kind of mechanism, I think need to have a special devices and special environment. And one of the other thing, like a quantum computer, consume a lot of power. So that's why it's to build a quantum computer is not easy and costs a lot of money. Currently, you see the IBM, they can build one quantum computer and consume up to about the 10 or 20 kilowatts, yes, just per hour, very large. And this kind of mechanism just very small. And in future, if you want to build a very high performance quantum computer, of course, they need more money to invest and sometimes more money to pay for about electricity, right? But that doesn't mean the quantum computer do not have a future. If you imagine just 50 years ago, we have the classical computer is equal to the one house, right? Or very big building, right? Similar to the quantum computer currently. The long 50 years ago, classical computer is equal to the one of large building, and now it's become a very small. Just you can bring it by the hand. And the future, if quantum chip and quantum computer, I think just follow the same mechanism. In the next 20 years or 30 years, the quantum computer becomes smaller and faster, okay? Similar to the classical computer evolution. And if you look more detail about the quantum superposition or entanglement, I only have one of online course, National Chung Chung online course only have introduction to the quantum computing, so you can look back see more detail about that theory. But you can see in the quantum superposition, that means they can maintain two states, 1 and 0 at the same time. For example, qubit 0, they can have two states for bit 1 or 0. They just different about the north and the south. They're just different angles between the north poles and the south pole. And quantum entanglement, that's the other specific, very special characteristic in the quantum computer, because this kind of two particles can link together. And this kind of one of fundamental theory behind the teleportation in future. For example, you want to teleport between the two far distance. You can use kind of this quantum entanglement. So you can move from the United States to Taiwan, maybe just about 1 or 2 seconds. It's too fast, or eventually it's faster. And one key point in the quantum that you can maintain two qubits, two different places and two for each other. So you still can maintain the state for 2 qubits. So that's a kind of special characteristic, and currently everyone still look more detail how they can exploit this entanglement mechanism to improve some, the technique, some technology. So the key point is next 20 years. So how the data security look? So we'll see the quantum computer can break and can crack AES. That's possible, okay? Remember the last lesson I wanted to mention. Yeah, it can take 149 trillion the years to brute force the AES just 128 bits, right? If you increase about the 256 or 512 bits, eventually it's much much harder to crack. But the quantum computer, you can break or you can crack that kind of password if you have enough the logical qubit. For example, to break about the AES 128 bits, the quantum computer require about 2,953 the logical qubit, so can break. And if you see currently 2024, this year is 2024, so state of the art the quantum computers, they have up to about 372 qubits. So I think next 10 years they can reach that kind of level, and maybe they can break this kind of AES. So the question is next 20 years, so quantum can break the RSA or AES 128 bits. That is yes, I would say yes. It's not 100%, but I think about 70% they can break this kind of algorithm. So that is why they use kind of post-quantum cryptography. Just this year, 2024, the NIST or standard organization in the United States just proposed four algorithms to replace the currently the cryptography algorithm. They can use LTRU or latex, or you can see on screen several mechanisms. Latest post-quantum cryptography. So they predict in the next 10 years, the PKI is broken, just a mechanism just got broken, and all the currently cryptography algorithm maybe just got cracked by the quantum computer. So that's why they need to replace quickly, just suggest a kind of replacement to the this kind of cryptography. So in future, so you can see the quantum safe the communication or quantum resistant. So algorithm they can combine with AES, or they can combine with some quantum key management like QKD, yeah, something mechanism to manage our communication in every network segment. So the key point, post-quantum cryptography will be replaced in every core security protocol like TOS, IPsec, VPN, and all the other ATPS, something like that. So it's too important. So that's why currently many countries just work on how they can implement that kind of new standard post-quantum cryptography to the kind of practical the current protocol. And okay, so the quiz. So over here we have several the question and something like is correct and something like true as not. So quantum computer use bit 1 or 0 to represent the data is correct, or quantum computer can break the current cryptography, or in 2024 the quantum computer is ready to use, or something like post-quantum cryptography is will be used to change currently the encryption algorithm. So which one is true? So maybe you can select first after you hear whole the thing and you see which one is correct. I think this one you can the second option. Quantum computer can break the current cryptography. Yes, this one is yes. But the first one is true, okay? And in 2024, quantum computer is ready to use. No, this one still under research, and commercial quantum computer need to take maybe 5 or 10 years to use. And the last question about post-quantum cryptography will be used to change the current AES or RSA algorithm. That is yes, okay? So second and fourth is yes. Yeah, first and the third is no. Okay, this summary, so just remind you the quantum computing and quantum computer is very top target for currently the research and development. So maybe in the next 20 years, the quantum computer can successfully crack the current cryptography, but for now it's safe, okay? To make sure it's a counter crack the possibility, so we propose the post-quantum cryptography. And post-quantum cryptography will be used in every core the security protocol like TOS, IPsec, VPN, ATPS, and everything. So please, from now on, maybe you can focus to study what is post-quantum cryptography. Okay, thank you everyone.